Shut up and sit down.
Hello everyone, so there it is. I've got all the temporary mounts for the electronics on there. It's ready for its test. I must say, I am a little bit nervous. I haven't plugged it in, I haven't turned it on, I haven't done anything like that. I wanted to do it all on video. I've got previous videos. One of them was called the prototype track. And in that video I go into great depth about how I built the track system and how the electronics are working. So if you want to get information about how like the drive axle is built, how the treads are built, I talk a great deal about this thing. This is the Dimension Engineering Sabertooth. It's the 2x12 controller. You can run 2 DC motors up to 12 amps each. This thing is ridiculously cool. It has onboard software that handles a lot of work, and you can do a lot of different things. You can control it a lot of different ways. You can plug it into an RC receiver and use that to control it. I've got it in tank mode right now, which means the software on board here is handling all of the logic for figuring out turning and driving. So the Arduino doesn't have to worry about any of that. It doesn't have to figure out how slow to or how much to speed up one track or slow down the other track in order to turn. This is using a packetized serial interface from the Arduino. So all you have to do, there's a library available on Dimension Engineering's website, an Arduino library, which makes it so ridiculously easy. You instantiate a software serial object, and you pass that to the constructor for the Sabertooth object. So now your Sabertooth object has a serial, and it's only a single line of serial transmitting from the Arduino to the Sabertooth. There's no data going from the Sabertooth to the Arduino, so it's a single wire interface. And there's two methods that you call drive and turn. Yeah, and that's it. It takes care of all the rest of it. It is so awesome. And you got drive and turn for each motor. No, sorry, that's wrong. You have, why did I do that? No, it's just drive and just turn. So you have 2 methods, and that's it. It takes care of everything. So easy, takes off so much of the work out of the Arduino. But like I said, go watch the prototype track video for extreme details about everything. Okay, so I have this ready to go. Back here on the computer behind me, or behind the camera, I have my software running. It's called the Tank Server. It's written in Qt, C++ with the Qt framework. I've got my Xbox One controller. This is the Bluetooth controller. Throttle is on the left stick, turning is on the right stick. I was going to have another piece on here. I was going to have a camera on here, mounted on a couple of servos to act as a gimbal for tilting, for tilt and pan. But it turns out the software I wrote to control all that isn't working as well as I'd hoped, so I need to find a slightly different way to do that. I built a box, and inside that box is another Arduino. It's a Pro Mini, 3.3 volts, so a tiny one. Has Bluetooth module in it, a SparkFun Bluetooth, so it connects to the computer via Bluetooth. And it has a MPU 6050, which is a breakout board for a 3-axis gyroscope, 3-axis accelerometer, and a temperature sensor. So that little box just kind of straps to my head, to the back of the head, and it tracks my head motions, left, right, up, down, and then that will control the camera. Now, the final tank will that will be controlling the turret, so when you look left, the turret will turn left, and when you look right, the turret turns right, and when you look up, the barrel will elevate, and when you look down. So all of that will be handled by a motion tracking system that I built. But when I was doing some testing, it wasn't working as well as I had hoped. It was glitching a little bit, and it wasn't as stable as it should have been. So I'm looking at a slightly different way to do that. But I didn't want to wait. So I'm babbling because I'm a little nervous about turning this on. I mean, this is the first go, right? I mean, all sorts of things could go wrong. There's two particular, when I get it out onto the road, there's 2 particular things that I'm actually worried about. One of them, which isn't so bad, is that these might get peeled off due to the friction and whatnot. They're all glued in with a thick or extra thick, no, with a thick CA glue, clamped and set to dry. So I know they're in there as good as they're going to get. Epoxy, the thick CA glue seems to work better than epoxy. I've even used 30-minute epoxy, 24-hour set time. But the CA glue seems to work better. But like I said, there's the possibility these could end up getting torn off. The one problem though that I really am worried about, because it's completely unknown, is that the gears, the 3D printed gears, could just strip, which would be horrible. And if they do end up stripping, that means I'm going to have to commit and rebuild this entire thing with pulley systems, and that will be a massive amount of work. Anyways, I think the stalling is over. All I got to do is plug it in, wait for this to start blinking, and then over here I connect. So this is a 915 megahertz transceiver. There's another one connected to the USB port on my laptop. You can see it right here. That's how the software on the computer is communicating to this. These are good for at least 1 kilometer of range. I use these on my big quadcopter, which I have had over 1 kilometer away, well, like 1 kilometer away, and I was still getting telemetry, so I know they have a good 1,000-meter line of sight, which is awesome. And the video system that will be on here is using a 200 milliwatt 200 milliwatt transmitter, which is again is good for almost 1 kilometer. So yeah, I'll be able to drive this thing everywhere, considering it's too big to fit inside a office. Okay, nervous as hell. Let's plug this beast in and see what happens. I'm just gonna have a drink here. It's not alcohol. It's just Pepsi, or just a cola, Coca-Cola. Well, it's no name cola. It's only like 10 in the morning. Is it? I'm nervous. I'm totally stalling on this, man. All right, let's do it. Let's do it. So there's 2 things I gotta test about this system. First of all, I just gotta test to make sure that it's actually, you know, working. When I drive forward, both tracks go forward. When I drive back, both tracks go back. And when I turn, you know, it does its turning thing. Right? I just need to make sure that it's working. The other thing I need to test is with the connection. So there's a heartbeat that the software on the computer sends to the Arduino. And it sends that heartbeat message every 500 milliseconds, so twice a second. If that heartbeat, if the Arduino doesn't receive a heartbeat when it expects it, it puts the saber tooth in the shutdown. It just stops the motors dead. That's to prevent any runaways. If you didn't have that heartbeat safety system, and for whatever reason you lost connection or the software crashes or something, and this stopped receiving data, the saber tooth would just continue running with whatever its last signal, or whatever its last command was. So if you're running at half throttle, and then all of a sudden you lose connection, this thing is just going to keep going at half throttle, and bye-bye. You know, shit will happen. It'll run into something, run over a kid, whatever. So I need to test that. What I'll do is I'll be running it on here at some percentage of throttle, and then I'm just going to pop this off, and that will kill the transmitter. And within half a second of popping this off, the track is just going to stop. Just a bang. All right, let's do it. No more talking. Okay, so first, this is just my battery monitor, my battery meter. That lets me know how much battery life is in there. Okay. No more stalling, is there? All right. Got a blinking green light, blinking green light. Let's connect. Failed to connect. Why? that's interesting. I don't have any lights on here. Something is wrong. Oh, crap. All right, be right back. All right, I'm back. So, what was wrong there? No, it's still wrong. Oh, did I damage it? Crap. Okay, there we go. So now I got my green light. So what happened is the power and ground, I had that plug in backwards. Dumbass. So now it's connected the right way, power to power, ground to ground. So let's connect. Still didn't connect. I have my baud right, yeah. Failed to connect. Do I have those backwards? I wonder if I've got those backwards. All right, I just got to do some debugging to figure out what I've screwed up. All right, boy, I really screwed up plugging stuff into that Arduino. So I had the power, or the transmit receive, the serial lines in the wrong place. Okay, let's try this again. Close the port, clear the output, connect. Still not fucking connected. Alright, what did I screw up this time? Well, oddly, I had to unplug this from the USB and plug it back in. So I know I could get a connection. I've put my tape back on, unplugged everything. I've got the servo running, set the port, 57600. Now, we should be golden this time. Blinking green light. Hit connect. Failed to freaking connect. Still failed to connect. What the hell? Okay, there we go. Now we got a connection. That's weird. Solid green light means everything's good. We got nothing happening here. Oh, I got to connect the gamepad. I'm really nervous and I'm screwing everything up. Okay, so the gamepad's connected. Oh, baby. What the hell's going on there? Okay, I'm going to make a small change to the software. Be right back. Alright, I'm back. This is really, really weird. This is my Xbox One controller. I bought it just a little while ago. Been using it for gaming. I haven't used it on this project yet. Now, there's a really odd thing about this. On my desktop, this stick, left and right, is access 4. On this laptop, the same stick, the same axis is actually access 5. That is just really messed up. So, I don't know what the hell was going on there. Anyways, I've fixed it. Took me a few minutes to figure that out. Okay, so let's try this again. So all plugged in, I got a blinking green light. Let's hit connect. Connected. Let's go forward. Backward. Left. I think I might have another bug in the software. Be right back. Hey all. Alright, so I fixed a small bug in my code. I slowed the updates down. I think they were going too fast and they were overloading the Arduino just a little bit. Anyways, it seems to be working fine. Gonna have to figure out some sort of exponential control on here. It's a little too touchy on the low speeds, but we'll find out what happens when I get it out on the ground. Okay, up next is the test for the heartbeat. Make sure that actually works. So I'm going to put the throttle up a little bit, then I'm going to pop this off, and we'll see what happens. Perfect. And yeah, that kills everything, so that's good. Let's do that again. Perfect. Everything looks good. Time to take it outside and let it run. Alright, y'all, I will see you all in a few minutes. Well, here it is, everyone. Moment of truth. Finally got a sunny day out. I've got my laptop and everything on, sitting on my bike over there. So yeah, this is it. I'm going to move the camera over here. So I'm just going to drive slowly in that area at first, and then we'll just go from there. Moment of truth. Let's plug the battery in. Blinking green light. And it's connected. All right, let's go for it. See what happens. Whoops! I got the steering backwards. Damn it! Well, that's not supposed to happen. So that's a bit too much grip. Gonna have to fix that. Gonna have to put more tension on the tensioners. I don't know if we'll be able to get this back on. How did that come off? Well, that must have taken some effort to get off, because it took a lot of effort to get back on. Alright, let's not do that again. So I've got the steering backwards, and I think I've already stripped the gear. Nope. Alright, let's keep having fun. How's my battery doing? Oh, well. Yeah, I'm not quite thrilled about the gears. You can hear them crunching every now and then. Well, let's find a bump. Glitching a little bit though, that's annoying. I got a bug in the Arduino code. Alright, let's bring this camera over here. Well, seems to be working. Seems to be working. I don't think those gears are gonna last very long though, based on that grinding you can hear. Full speed is definitely fast enough. Let's see full speed. Kind of thought it was going to be faster actually, but well, there we go. I definitely think I'm wrecking some gears here. You know, I could change that gearing for sure though, but I don't know if I will. Alright, so that's fun. I'm gonna just play with it a bit. Well, there it is. I'm almost out of battery power on my camera for some reason, so I'm going to have to make this short. It's definitely a success. No doubt about it, it's a success. Do have a bit of a problem with the gears going in reverse. I think I know why. I'm not entirely sure how I'm going to fix that. But they are slipping in reverse. You know, I'm tempted to actually just switch the belts. I really am. Otherwise, everything worked well. I did discover there is one safety feature that I need to figure out how to implement. Apparently, when the batteries die in the controller, it just runs away. So there's me running down the street chasing this thing, and it started spinning in circles. And yeah, that was not good. So I need to figure out what happens when the battery dies on the controller and how to handle that. Another thing I'll mention is that the shocks. So I mentioned previously in that other video, I had the green shocks, the green springs on the shocks. So I've upgraded to these red ones, which are actually from a different big bore shock. So I 3D printed some additional rings on them so that they fit properly. And I replaced the oil. The shocks come with a 20 weight oil. I replaced it with a 50 weight, which works very well, I think. So all is good. Otherwise, yeah, it's 100% success. Hello. Interesting that the track peeled off while doing the big pirouette. So I think I'm going to have to put just a bit more tension on here just to make sure that, and that's easy to do actually. There's just these collars that are behind the spring. This collar right here, at the spring. I'll just make a longer one and I'll put more tension on, so it's easy fix. Otherwise, I'm not happy about the gears slipping as much as they are. That's a bit of a problem with those gears slipping that much. You can hear them, right? I mean, you heard it all throughout the video, the grinding, slipping gears. But like I said, I know why. I just don't know what I can do about it. It might really be worth just redesigning that whole thing into pulleys. The pulleys will slip, sure, but it won't be as bad. I don't know. I'm going to have to think about that. Anyways, really the next step, if I just go with what I've got, the next step is to start working on the body of this. So that's going to take a long time, so don't hold your breath. Otherwise, I'm very happy. And, you know, I can change the gearing, reduce the overall torque of it. I mean, it's got serious torque, and increase the speed of it. I was expecting it to be a little faster. So, again, if I go with the pulleys, the pulley system I designed actually used less pulleys than I'm using gears, and I did reduce the gear ratio a little bit. But I think I can even reduce it more, which would probably be a really good idea. Because when you're using the belts, they can't really handle as much torque as a gear can for the most part. I think I'm going to do that though. Anyways, very successful run, all looking consider it. Didn't lose any pads. I didn't actually strip off any teeth on the gears, so I know the gears hold up. So what's happening with these is that these 3mm shafts, they're fairly long, and when they're rotating in one direction, they're sort of pressing against each other because of the angle that they're on, but then when it goes into reverse, they start pressing away from each other, and that's allowing this one idler gear that's in the front to actually kind of bow out. And that's causing it to slip, is because the 3mm shaft is just flexing. And that's a problem. But I think I know how to, there's possibilities I'll have to dig into and figure it out. Anyways, that's it. Thanks for watching my video. This is my 3D printed tank track system. It's definitely successful, no doubt about it. Got a little more work to do on the software. There is a bug in the software still. I got to figure out. You'll notice that it was still jinking a little bit, and I don't know why. So I'll work on that. All right. Well, thanks for watching, y'all, and I'll see you around. Bye. All right. So this is a couple of days later. This is an addendum. I did some more testing with it, and the skipping of the gears got worse. One of the shafts is now actually just a little bit bent, and you can see it's bent. Just a lot of pressure on there. So I've decided I'm just going to commit to redesigning the whole drive system, and I'm switching it over to belts. I like the belts. It's a sleeker idea. It's quieter. This is just a project. I'm in no hurry to finish it, so I'm just going to go ahead and do it. But if we take this, and I don't know if it'll show up on the camera very well, but you can see that drive shaft is now bent. So one thing I could do is I could actually just put blocks, redesign the walls and put big blocks on and use a shorter shaft, and that would solve that problem. But, and the gears held up really well. Even with all that slipping, they didn't strip, but it is wearing on the gears. So you know what? I've already started on the redesign again. I've committed to just doing the whole thing. I pretty much scrapped the existing design, and I'm starting all over with no constraints at all of any kind. So it's going to be a lot of work, a lot of rebuilding, but whatever. Code-wise, I still have a problem with the code. I had a runaway again, a second runaway, and I don't know why. There's another thing where, and you'll notice it in the video that you just watched. As it's running, it'll suddenly, the motor sort of stop and then start again momentarily, that jerkiness, and I can't figure out what's going on there. The code on the Arduino is really quite simple. There's not a lot going on. It just receives the message, parses it, and outputs it. So I'm going to have to do some serious debugging on that to figure out why it's doing those skips. I don't know. I really don't know. It's got me baffled, but that's okay. So yeah, the next video is not going to be for quite a while as I go through all the work of redesigning these. One of the hard parts about the pulleys, which I've mentioned before, is that you need a belt tensioning system. And when I did the previous redesign attempt to use pulleys, I was getting them to fit, but then when I started trying to figure out how to do belt tensioning, it just broke my brain. I wasn't going to work. So starting again with no constraints, I've removed all of the tubes. I've pulled this mount. The whole system moves over a bit so that it'll clear the wheels. It's going to be longer because there's going to be a belt here, and another belt back. And the tensioning system is going to be the tricky one. So I'm working on that. So like I said, the next video won't be for a while. Otherwise, I really am quite happy with the gears. Overall, they worked wonderfully. I guessed on the gear ratio. So these motors are from the Traxxas Emax. These are Titan 550 12 turns. So I used the same gear ratio that's on the Emax, at least I thought I did. It should have been 40 to 1. I mentioned in an earlier video 60 to 1, but that turned out to be wrong. I hadn't seen the numbers in a while. So I'm reducing it down to 37 to 1. So that'll give it a bit more speed. This thing's got torque up the yin-yang. Now, that's no problem. I haven't quite decided yet, but I could even go down to like maybe even 35 to 1. I don't know. I think 30, you know, it wasn't slow, that's for sure. And going up to 37 to 1 will speed it up a good amount, and I think that's probably good enough. So overall, I'm very happy with the track system. I know if I put a little more tension on those idler springs, the track popped off when I was doing the pirouettes with it, but that'll be solved just by adding a bit more tension. Again, that was just a bit of guesswork, trying to figure out how much tension to use to start with. Easy fix. Like I said before, just put a slightly longer tensioning spacer in there, and we're done. Otherwise, yeah, the thing worked brilliantly, and I'm very happy with it. I expected, you know, small problems, and that's all I got is really small problems. No gears stripped, none of these pads popped off, so I know the CA glue that I used was a great solution. And overall, very happy with it. The other thing that's going to happen when I make these gears, even though I pulled this out about 7 or 8 centimeters, the whole gearbox is actually going to end up being thinner because I'm changing the configuration of the gears. So right now I've got the drive gear going to a set, going to another set, going to another set, going to the final. I'm actually going to remove one whole set, so there's only going to be 3. The main gear will go to this one, which will go to this one and here. And I'm changing the configuration of it and flipping one of them over, so I'm actually going to be able to make this narrower. But the motor is also going to move. It's going to move somewhere up here. I like that idea because it'll move that heavy weight, because you notice this thing is always way back here. But it's also going to kind of interfere a bit with the turret, which kind of bugs me a bit. So I don't know what I'm going to do there. I'm going to try not to move it too far forward, but at least it'd be nice to get it somewhat forward, but I can't go too far without it interfering. Anyways, so that's my track system. I know people are asking for STLs and whatnot. Don't bother. I'm not going to be posting any STLs for this because there's just, you know, dozens and dozens of parts, and posting all the STLs would suck. If I get around to actually posting anything, I'm just going to post the step file for the whole project. And, you know, if you want it, and that's not going to happen for a very long time either, so don't worry about it. But if you want it, you know, that's what you're going to get. I use Fusion 360, which is a great CAD design software. It's absolutely awesome. So I'm not, like I said, I'm not posting any STLs for the individual parts. The other thing about, if you were to try to make this, you're going to have a hard time. There's a lot of, you know, unique pieces, like the fiberglass rods, and the double fiberglass drive shafts, which I explained in a previous video about how to make. And the amount of hardware, screws and nuts, you're looking at hundreds of screws and nuts. So I know it'd be fun to look at, and you might think you want to build one. And also these shocks. Turns out the shocks are now discontinued. You can't even buy them anymore. So you'd have to find a replacement shock. And yeah, so posting the STL files just really wouldn't be worth it. Anyways, I'm going to go back to work and do the whole gearbox redesign and tests, and we'll see what's up. Anyways, so thanks for watching, thanks for commenting, and I will talk to you guys whenever I get around to it. Bye now.